This presentation is delivered by the Stanford Center for Professional Development.
When we get to the Q&A session a little bit later, we'll take questions both from the live audience here and also from people who are watching over the web and can send their questions that way. So we're here tonight to celebrate and to congratulate Andy Bechtolsheim for his induction as a Stanford Engineering Hero. The Stanford Engineering Heroes program was started actually just 2 years ago. And it's intended to recognize engineers who have an affiliation either as a student or as a faculty member or in some other way with the School of Engineering, to recognize people who have advanced the course of human, social, and economic progress through engineering. And of the 16 heroes to date, you'll recognize many of the names. These are people like Bill Hewlett and Dave Packard, Vince Cerf, Brad Parkinson, who was the inventor of the GPS systems, and Intel former CEO Craig Barrett. So it's a very distinguished group of people, and we're delighted tonight to welcome Andy into that group. Unlike many award events, when we celebrate these heroes, we simply ask them how they would like to spend some time at Stanford. And Andy chose today to spend some time with some of our students in EE and CS primarily, and have dinner with them and talk about life and talk about starting companies and talk about venture capital and so on. And then he said he would like to give us a talk this evening on the process of innovation. And this is a topic, obviously, that is of tremendous interest to the School of Engineering and to all of us here. And so we're just delighted that Andy picked the topic of his talk, which you see up here. So Andy, as all of you know, I think is probably best known as a founder, or first known perhaps as one of the founders of Sun Microsystems. But his reputation and his experience extends well beyond that company. He's co-founded 3 companies since then, and the most recent being the title you see up here, Arista Networks, which is a company that's involved in cloud networking, where he's currently chairman and chief development officer. Andy is also a rather legendary venture investor. He often recognizes before many of the rest of us the opportunity and the potential of an idea. And there are many, many examples. He may talk about some of them this evening, but the one, of course, that probably is best known is he recognized the potential of a couple of other Stanford students who formed a little company that is now called Google. And Andy was the first investor in that company. His career as a technology innovator and entrepreneur actually started when he was in high school in Germany. At age 16, he developed a microprocessor-based system that could be programmed to control a milling machine, and he licensed the system to a local manufacturer. And it turned out by the time he graduated from high school, he was actually making more money than his father was through his entrepreneurial activities. So not surprisingly, that led Andy to think about a career in computer science. He studied electrical engineering at the Technical University of Munich, and then received a Fulbright scholarship to come to the United States. And first he went to Carnegie Mellon, where he got a master's degree in 1976, and then he came to Silicon Valley in 1977, and I guess he's been here ever since. He took a summer job actually here at Stanford when he first arrived, but that fall he enrolled here as a PhD student in EE and CS. And his advisor was Forrest Baskett, who was a faculty member at the time and is now a venture capitalist in Silicon Valley in his own right. And he was telling me over dinner that this was a very propitious connection that he made with Forrest, because it turns out that Forrest was on sabbatical the first year that he was here or something, and so Andy actually got to use his office for his graduate work. So I think that says something about picking the right PhD advisor. I don't know. So Andy has received many, many honors for his work in the Valley here and for starting companies, for mentoring young people. He's received the Stanford Entrepreneurial Company of the Year Award, the Smithsonian Leadership Award, and he's a member of the National Academy of Engineering, which is really the highest honor that can be given to an engineer. So tonight we celebrate him as the most recent of the Stanford Engineering Heroes. And Andy, we have for you a replica of the plaque which hangs on the wall, just down the wall here, where we have sort of a hero's wall. And so thank you for coming back to Stanford, and we're all looking forward to your talk this evening.
Thank you very much. Yeah, thank you for the very, very kind introduction, and thank you all for coming. You know, when I was young, I actually grew up on a farm in Germany. And as a young person, I decided the most interesting thing is to actually figure out how things work. So I started life taking my dad's tape recorder apart and putting it back together and so on. But I was mostly interested in computers. And this was back in the 60s when, personal computers was just a dream. I always wanted to learn more about computers, which is why I came to the States, and I guess I picked the right school here. I was also interested in how to translate this kind of knowledge to a business venture, which is what I did afterwards. But what I want to talk to you about is the essence of innovation, all the kind of good things that happened here. And it's impossible to start talking about this without showing a picture of the great university where we are, which arguably has generated more innovations and more startups and more business successes than any other university on the planet. So the statistics are still forthcoming, but there's a person in the business school who's actually writing a book about this, and I think it's now 10,000s of companies that can be traced back to Stanford alumni and Stanford students and Stanford faculty and having a connection with Stanford that employ millions of people. I just picked a few of the better-known logos up here that first came to mind, but again, there's hundreds or thousands of companies behind this. And one that particularly mentioned NVIDIA, which is one of the persons here having sponsored this beautiful building we're in. Now, this is sort of the quiz question, which is how many startups really came out of Stanford? I used to think it was thousands. So there's an official count on the Stanford Innovation website, which is 6,000. But according to Chuck Easley, that's running the book, it's actually closer to 40,000. So I haven't seen the whole list yet. But basically, it is just the innovation center of the universe. And it certainly helps to be in Silicon Valley for this. But going back to technology, the areas that I'm most familiar with certainly is, and what really drove this revolution that we have all witnessed, is a combination of chip technology. There was just incredible progress there. Then networking, communication, the whole web effect, and ultimately open source software, which enabled people to work together more fruitfully to develop new things. And there is this fountain of youth here in Silicon Valley known as Moore's Law that really underpins a lot of what has happened here. And I just want to spend a few minutes to explain this. So Dr. Moore actually came up with this idea even before he co-founded Intel, that the number of transistors would double. I think it was originally doubled every year, but it's really every 2 years. And he predicted this back in 1965, and they barely knew how to make an integrated circuit. Now, if you look at the curve, so the dotted diagonal line is his prediction, his model, and the big dots are the various microprocessors that, in terms of number of transistors, and at the time they started coming out of the shipping. What you can see that is for the last 40 years, the evolution of microprocessors was straight on this line. It's an amazing ability to predict the future 40 years in advance if this improvement is a factor of 1 million in 40 years. So if you double every 2 years, it's a factor of 1,000 every 20 years, and 1,000 times 1,000 is 1 million. There hasn't been anything like this in the history of mankind. I think that's safe to say. And basically, you can buy, a million times the transistor count or the compute power today for the same cost as 40 years ago, which is the most amazing cost reduction. Now, the good news here is that this curve is continuing. So we're not at the end of Moore's Law. There's an industry semiconductor association that sort of publishes these roadmaps, which involve the work of a lot of people on the manufacturing equipment side and the process side and design tools and everything. And at least for the next 12 years, it's sort of in the bag. Basically, we would expect another factor of 100 between now and 2022, 2023, meaning the cost of computing would go down that much just the next 12 years. Now, there's reason to believe that it doesn't end in 12 years either. It's just the industry roadmap doesn't go out any further. So maybe by the time I truly retire, it will be another factor of 1,000 in the next 20 years, which would be then altogether a factor of 1 billion from the start in 1971. So this is really, really unbelievable. And it kind of raises the question, what could you do with 1 trillion transistors on a chip? So One thing, of course, is one can build bigger memory chips. In fact, today's memory chips are pretty dense already. The latest flash chips store 64 gigabits per silicon chip, and then they put 8 of them into a package. So it looks as one package, but it's actually 8 die. So that would be 64 gigabytes in a package. That's today. They're predicting 256 gigabytes in 2014 and a terabyte in 2016. So your future iPhone or whatever will have a terabyte just in a few years. On the CPU side, it usually comes down to more cores. Could be special function units, could be floating point, could be parallel units. But basically, factor of 100 next 10 to 12 years. And this is a logarithmic curve, so it looks like a straight line, but it's actually a logarithmic scale. I linearized it here to make it a little more clear what's going on here. So today's Intel chip has 8 cores per socket, 16 cores in the dual socket. The next one will have 16 cores in the socket, the one after that 32, and so on. And it's just amazing how these continuously improving, exponential kind of functions, what happens 10 years later. So based on this prediction, 1,000 cores in 2022. And of course, at the inverse cost. So again, if it costs too much to compute something today, it will be 100 times cheaper in just 10 years. So summary here, the Moore's law is alive and well. We don't have to worry about the future yet. We have seen a million-fold advance just the last 40 years, and we expect at least another factor of 100 in the next 12 years, if not a factor of 1,000 in the next 20 years. And there truly hasn't been anything like this anywhere else on the planet. Now, let's talk about how this then played out at the system level. And for those of you who remember, those were the 70s. The first Apple I, wooden box, not as fancy as today, but it actually worked. Over at Xerox PARC, they had a much more fancy machine known as the Palo Alto computer, which was the first workstation, which was a great inspiration to me, seeing that in action there. In the 80s, we had the Apple Macintosh, IBM PCs, and Sun workstations. In the 1990s, we had laptops and cell phones and MP3 players. And in 2000, we have iPods, iPhones, and iPads. So there was a clear evolution here to mobility, miniaturization, things getting smaller. And what is true about this is that today's iPhone or iPad has a horsepower that far exceeds the laptop from 10 years ago or the workstation from 20 years ago. It's no comparison. So that's all understood. On the communication side, things actually took a little longer. So for those of you who remember this, the ARPANET was actually conceived of as a memo in 1965. It took 4 years to build some, what were they called again? Some box that could send a message to each other. And then Vint Cerf, who is another alumni here, invented TCP/IP in '73 because they were about to run out of the 8-bit addressing. The original ARPANET was limited to 256 nodes. And then it took a while for this to go. So the ARPANET in 1971, you can still see Stanford on this list. There was actually 13 universities connected, and email actually worked. You could transfer files. It was actually very useful. 56 kilobaud lines, but it still worked. Our ARPANET 1976, I think it had about 57 nodes connected back then, again, all universities. In 1977, it got a little bigger. It barely fit on a slide. And then, one had to change protocols because of the original ARPANET address limitation. Today, this is a picture from Facebook of their simultaneous users, 900 million users in the world, or whoever is online, talking to each other. People are everywhere except at the Antarctic and the North Pole. But every other point on the planet is connected. I think they even have internet on the South Pole. They must have it there. Okay, so everybody's connected today, and everybody can use all these things that were available only to academia back then. Now, Ethernet, which is the way that computers actually talk to each other, at least in the data center, also took a long time to really take off. So it was invented in 1973 at Xerox PARC by Bob Metcalfe. The first version was 3 megabits. The first industry one was 10 megabits. Now, a personal story here. So I was a master's student at Carnegie Mellon, and my thesis advisor was Sam Fuller, who was another graduate from Stanford. And he did visit, his old alma mater, and he had a chance to stop at Xerox PARC. And he came back to Carnegie saying he has seen the future, and it was Ethernet. It's like this cable that would just connect things. Because back then it was inconceivable that it would be that simple. It's just at this one cable. And little did I know that I am, today, 35, almost 40 years later, and I'm still working on the same thing. So just a little faster now. But fiber communication, the first low-loss fiber was invented in 1965. the initial fibers had 20 dB loss per kilometer, which means you couldn't connect anything more than a few hundred meters. The first really low loss cable came in the mid-70s. So back then, they didn't have fiber, right? This really took off in the 80s and 90s. And today, of course, with dense WDM wavelengths, division, multiplex, you can do terabits over one fiber. So one thing one can learn from the old days that is it can take a couple of years. In particular, all the examples I showed you took at least 3, if not 5 years from the day of invention, the first idea, to the first prototype, and then another 3 to 5 years to get into any kind of commercial adoption, and then another 5 years, if not longer, to get to wide-scale adoption. So in the old years, in the old era, it could easily take 10 to 20 years for a new idea to come to real fruition, commercially speaking. But everything changed with the web. So in web time, things happen a little faster. So let's go to history of web browsers. Tim Berners-Lee invented the first browser at CERN in 1990. It was then ported to Unix and DOS in 91. Then they added graphics, display things, which was very useful. And in 93, Mark Andreessen did the first release of Mosaic at NCSA. In 94, he founded Netscape. In 95, he went public. So it's time from startup to IPO 1 year, and those were the good old days. Now, one thing to keep in mind here is there was a lot of web browsers at the time. There was at least 30 browsers, things like the Charlotte browser or the Planet Web and Get It Right. None of these, of course, matter anymore. But Netscape won that war, the first run at least. Except they made sort of one mistake, which is the business model they were in was actually not sustainable, because then Microsoft was just going to give it away, right? And the other thing they missed is that the front page was actually the most useful thing, because they could have done some search button there, but they didn't take advantage of that. So the unsolved problem at the time, and this is now 1995, was how do you actually find anything on the internet? Now back then, there wasn't that many sites, so if you knew where to go to, you could find this stuff. And we had Yahoo, which was the first sort of IPO company that organized the web's information. And it was actually a very well received service at the time, meaning you could actually find stuff. And it was like a newspaper, right? They would have editors that would select the best of websites and put them into the sports column or the business column and so on. But to find random stuff that wasn't categorized, there was Alta Vista. I'm not sure you remember that. It was an engine where they simply looked at all the keywords, in the page, and you typed in the word and would see which documents in their index would match it, and then we'll pull out these documents. But the problem was that as soon as people realized how the algorithm worked, they would add these sort of dark pages behind the documents. It would be the whole dictionary. So whatever you search for, the whole goal was to get to the top screen so that you would click on it at random. But pretty soon, at least I remember, I couldn't find anything on Alta Vista because everything just got overloaded by this sort of dark page spam thing. So then there were all kinds of search engines, Webcrawler, Infoseek. Infoseek actually worked pretty well. Lycos, Alta Vista, Dogpile, Northern Light, and Yandex. And then there was Google. So Google was not the first search engine, it was actually the last one. Most people don't realize this. And Google, back then, this is 98 now, looked pretty much the same way it looks today. Here's the search button, here's the I'm feeling lucky button. Now they have the social web thing on top. But basically, the essence of their idea and the business plan was that to really find stuff, it's really important to be able to find stuff on the internet. And in particular, as there was going to be billions of web pages, and you can't do it manually to sort this, so it has to be some automatic way. And the basic notion, which is just like in scientific publishing, which is it doesn't matter how many papers you write, it matters how many people cite your paper, applied to the web, was the solution. So the whole page rank algorithm was the essence of the technology, and it did work really well. Now, the second idea, of course, was that while you're searching for stuff, if you then find a relevant ad that corresponds to what you're looking for, that also should be pretty effective. And sure enough, even today, sponsored link advertisement on Google is, except for free email, which is the cheapest, is still the most cost-effective way to reach a large audience. It's unbelievably effective, which is the whole essence of Google's growth and success in the market. So a great story, and interesting enough, Google, excuse me, most people don't realize this, but the company really took off only after the dot-com crash. In fact, it made very little money before 2001, because in the old days, people spend most of their advertising dollar on banner ads, sort of the Yahoo banner ads where you never really click on, but you get sort of an image like TV advertising. But then, when the .com crash hit, people realized they wanted to have more effective advertising, and sponsored links and relevant links were just much more effective than banner ads. So that's Google. Now there was this other little problem. How do you, besides finding the things on the internet, how do you find the people on the internet? And sure enough, there was at least 100 social networking sites since 1987. And again, the one that is by far the most successful one was not the first one, but it was pretty much the last one that got started. Facebook was really only becoming available outside of Harvard and a few places in 2006, just 6 years ago. And obviously they have now almost 1 billion users with 100 billion pictures, adding 250 million pictures a day. So it's a huge success in terms of the number of people using it, and obviously went public recently. So lessons to learn here is that on the web, the time from invention to adoption can be very, very short. And you do not have to be the first to succeed, but you have to solve the right problem. And that is, being first at that is basically the most important thing, and then keeping it up with ongoing innovation on the web. So this is just a little history of the web and systems and Moore's law. Now I want to switch to what do people do to actually accelerate innovation in their respective companies. And there's different ways of doing this. One is you can start your own company. So if you have that opportunity, that's always a great one. There's a lot of advantages of being a startup company. One is you have a complete white sheet of paper. You have no installed base. You have no customers, no legacy systems. You can use the best technology that exists today to solve the right problem. You have no resources wasted on past things. And your entire little company is focused on this just one new idea. So this has worked well for a lot of people, especially in this valley. Now, there are some disadvantages, which is, you're small. You have very limited resources, both people and money. You're dependent on kindness of strangers, and it does take time to build these products and set up distribution channels and so on. Now, most people actually work at large companies, quite frankly, and large companies have the same problem. They also want to innovate. So they have this advantage that they have a big existing business, and they can put new things into the existing channels. But the disadvantage is, and they have plenty of money, right? But the disadvantage is they tend to focus on sort of more in the past and the future. And we'll talk about this a little more later on. But between having lots of opinions what should be done and most of the business being legacy stuff, it's actually harder to innovate quickly in large companies, except if it's like the best of best large companies than in small companies. And this leads sort of to the basic, $1 million or $1 billion question in industry, which is how do you actually accelerate innovation? Do you spend more on R&D? Do you do more brainstorming? Do you do more focus groups to collect more input? So I wanted to show some examples how wrong common assumptions are on these very important topics. So the first quiz question is, guess which high-tech company spends the least amount of money on R&D, on a percentage of sales and profits? You may know the answer. It's Apple. And it's actually stunning. They're spending, it's actually the best way to look at R&D is as a percent of product margin, which is how much money you actually make. Apple spends less than half of the percentage of margin than an HP, 1/3 of IBM, 1/5 of Intel, 1/3 of Cisco, and 1/4 of Microsoft, roughly. So how do they do it? Well, very simple. Their whole corporate philosophy is, less is more, simplify, simplify, simplify. So Apple, as you all know, has the simplest product line of any company in the world. They have exactly 5 hardware products, different variations, but basically these 5 products, and then some, beautiful software that supports all this. But advice from the late Steve Jobs is, the hardest thing in life is to say no. And they have done this very successfully and have essentially focused on the stuff that matters. Now, there have been consultants that have studied this thing across the whole industry. There's a study from Booz, Allen Hamilton on 1,000 companies, and they found no correlation between R&D spending and actual innovation success in the market. It's sad to say that's the case. It's basically the process of innovation that counts, not the pocketbook. Now, next quiz question is, guess which high-tech company spends the least amount of effort with customers or focus group to define their roadmap? Same answer. This is a quote from Jonathan Ivey, their Senior VP of Industrial Product Design, which says, we don't actually look to our customers for ideas or for assurance that what we're working on will actually work. We don't use focus groups, we just look at ourselves. Now, having said that, it helps if you have practice at this. So what Apple really has done at the end of the day is they took ownership of innovation, right? They basically said, if the future is going to be invented, it's going to be invented here in Cupertino, and say no to everything else, right? And then whatever they're doing really, really well. So with these very simple, three-step formula, here's this company that is now the most valuable company on the planet and have arguably had more innovation and more change effect on people's behavior than anyone else. But the truth is, not everybody's Apple. Most companies are much more complex. They have thousands of products. Take HP, right? They have everything from nuts and bolts to servers to laptops to you name it. And in many cases, these companies have grown by basically adding product lines or increasing complexity, which is a painful way to grow, but that's the thing. Having said that, every company can still simplify. So advice for big companies out there, simplify has its merits. But going back to this question of where do the inventions, the innovations actually come from? So people have studied this as well. The most likely place for innovation is, not surprisingly, the employees of the company, which would make sense, right? If you're in the business, you think about this stuff every day, you're trying to solve these problems in a better way, you are the source of innovation that should drive the company forward. Now, business partners, customers can be as useful. The customer has a particular problem that needs to be solved. That's inspiration for innovation. Things like the actual R&D department is kind of way on the list, and academia is low, but I think that's because there's not that much connection between companies and academia as there perhaps should be. But the truth is, it's really the employees that come up with the ideas, right? And what matters, of course, is to translate these ideas to great new products. And the perennial question is, why is this so hard, in particular in large companies? So it's a basic problem of sort of funneling the best ideas down and actually convert them to execution mode, because at the brainstorming stage, things are really easy or free. No money is being spent. As you actually design stuff and put them into production, a lot more money is at stake. And the spending pattern is basically that almost no money is spent on the invention stage. But the inventor invents something, and great, we invented something new. To actually get this invention to market costs more and more money the closer it gets to market. And unfortunately, the focus in most established companies is at the tail end of this, because that's where the money is being spent. So arguably not enough time is spent on the front end where new ideas are being generated. Basically, companies need to pay more attention to this discovery stage, because without invention, nothing comes out at the other end. And then there's this whole problem of the ROI. ROI stands for return on investment. Now, the folks in the business schools of the world and any financial organization have perfected this to spreadsheets you wouldn't believe. You can basically dial in market share, market presence, marketing costs, engineering costs, you name it, and outcomes. Is this worth doing? Well, if Apple had done this, we wouldn't have iPods or iPhones or iPads today. The simple reality is, without great products, you cannot win in the market. So what matters much more than the ROI formula is actually to build perfect products, not to do the math behind it. And this leads to the next topic, which is the horizon effect. So this is something I learned about while taking my first artificial intelligence class. And in AI, it basically means that if you have a limited search algorithm, like playing chess, that the computer looks three steps ahead, and your good move of the fourth move, you will never find it, because it's beyond your horizon. And with limited search, of course, you will never get the optimal answer. Now, applying this to human psychology is, quite frankly, nobody really wants to pursue goals beyond their horizon. I mean, people don't do things if they don't see how they get there. And this was kind of like the world was before Christopher Columbus, right? Nobody would go on that ship going into the uncertainty of what could happen. Now, unfortunately, in the real world, I'm talking, Wall Street mania here, there's this very strong quarter-to-quarter mentality where people are trying to make the numbers every quarter, and everything that's being spent too much has to be delayed or cut back or whatever to make the numbers. It is generally understood that this is the greatest inhibition to more creative initiatives in companies, because most people who work in a company are focused on the current, the next few quarters out, and that's how it works. Now, at the same token, nobody wants to start a project if you don't have the resources to complete it, right? It wouldn't make any sense. It's just a waste of time. So between sort of the time horizon and the resource horizon, in particular if a project is perceived to be risky, a lot of things just don't get off the ground. which is not the problem you have in a startup company where you pursue that new goal, but that's the problem you typically have in large companies. So the net result of all of this is that most funding in established companies is applied to safe bets, meaning things that are predictable, that have good ROI, and very little, if any, funding is applied to risky bets, except for some long-term research that usually doesn't have anything to do with the market. This does not accelerate innovation. And to get beyond this, one has to actually look at things a little further out and focus on innovation that can actually get stuff done that is effective and gets delivered. So, of course, people shouldn't bet everything on the future and they can't bet everything on the past. So there has to be some distribution of investments. And I copied from somebody's beautiful presentation this curve that basically says you want to spend most of your money on the safe, low-risk bets and then some on middle things and then some on really radical things. But basically, innovation comes down to managing this curve. Right? There has to be stuff that is more revolutionary, that's further out, and even while most spending is applied to less risky bets. And it's the companies that have managed this curve effectively that really excel. So let's talk about then also, why do some of these great new ideas fail, including startups, that pursue them. And believe it or not, there's actually very few reasons why startups fails. There's basically only 5 things I can think of. The number one reason is you're too early. If you're too early to market, it doesn't help. The second one is you're too late. That doesn't help either. Number 3, it's too difficult. You just couldn't get it done, or it's just not relevant to the customer. That's a really bad one. Or it became too expensive. There was no value proposition. But those are the 5 basic reasons why things don't succeed. Now, the inverse of that is if you're to market at the right time with the right product that's relevant and has the right sort of value proposition, it's very likely, if not predictable, that it actually will succeed. So avoiding failure is actually fairly easy in my book. And then there's this whole other risk is if you don't try things, you're not going to succeed anyway. So anyway, there's no alternative to risk something here. So just a few examples of companies, of well-known companies that have been doing things differently. One, of course, is Apple, which, 15 years ago, was on the verge of bankruptcy. I mean, this is truly one of the most remarkable turnaround stories in American history or world history. And expanded on very, very successfully from the initial, iMac and MacBooks to iPads, iPods, iPhones, iTunes, and all the beautiful things we know. I think what's particularly impressive is how they combined beautiful designed hardware software with the internet cloud so that loading your applications, loading music is just transparent and works like a snap. And the success of all the things speaks for itself. Now, if one looks behind the curtain a little bit, Apple obviously was totally focused on what you would now call the digital consumer opportunity, which they always wanted to do as a genetic kind of thing, and they were just the first company that really focused on it and did it really well. And they understood that simplification with the consumer was absolutely key. Designing beautiful products is, of course, also very important. But then this combination of well-designed hardware, software, and cloud is what made the company. And they have now this, internal Apple University, how they teach their new employees how to invent the next big thing. So Apple has done marvelously well and essentially had no product fail in the last 12 years. The whole corporate mission is, innovation. It's deeply ingrained, and result is the highest market cap in the world. Google is, of course, the biggest search engine on earth, and it was that for a while, by the way. But also the company has expanded to many, many areas beyond search, most recently into the Android kind of smartphone systems. The Chrome browser is gaining rapid market share. YouTube, of course, has been a huge success, and so on. Now, Google has a somewhat different culture than Apple, which is they like to hire people right out of school, so they're not yet entrenched with the wrong, indoctrinations. I think they still have this thing where you get 1 day a week free to just think about stuff, which sounds like a good idea if it works. And they do claim that a lot of their best ideas came out of that 1 day a week thing. But more importantly, they set themselves very, very aggressive, very large-scale goals. Basically, they're trying to solve, or they expect that they can solve the impossible problem that nobody has solved before. And this needs a lot of smart people, of course, but they have been doing this in a consistent fashion. So we would expect Google to solve the next impossible thing. Now, the results is that it has been a true innovation engine, and they ended up with something like the 3rd highest market cap in the IT industry in the US. And we would obviously expect them to do yet more great things in the future. Now, a completely different company, Amazon. So here's a company that started off selling books on the internet. Very convenient, you don't have to go to the bookstore anymore, and it's cheaper. But who would have guessed that they have expanded not just successfully to other things they can ship, but now they are in electronic books, the market leader in e-books and e-magazines, and they are in fact the biggest cloud service provider on the planet by a long shot. So here's a company that went from retailing books to reselling compute cycles very successfully without losing a beat. How did they do it? Jeff Bezos is very keen on people who like a rapid rate of change. So that may be a good thing because he likes change. He likes to keep a lot of ideas percolating, try a lot of ideas at the same time, see what works, and basically use tools and structure to make the world a better place. So it worked great for them. All of these companies have led with innovation to define their current success. If these companies had not innovated on an ongoing basis, they wouldn't be nearly in the position that they are today. And the same lessons can be learned for other smaller companies, startup companies, following these particular very successful examples. So bottom line, a culture of innovation really helps, paying attention to the brainstorming front-end phase, avoiding the horizon effect, basically getting started with the projects that really make the difference, choosing an appropriate risk profile, not too much risk, but not too little, and then focus to get this all done. Since at the end of the day, innovation is the never-ending search for better solutions, and there's so many problems left out to solve. I wouldn't know how to start. But basically, whether you think about joining or you are at a small company or a big one or start your own company, there's just a ton of opportunities in the world we're in that need better solutions. So I think that's the last slide I had. Thank you very much for your attention.
Thank you, Andy. So we have a good amount of time for questions or comments. I think there are microphones up in the ceiling, so if you just talk loud, then people will be able to hear you, I think. So that's the first question.
Good.
Yeah, can you elaborate on what you mean by focus on the front end? That bullet here.
The thing is, once you get going with whatever project you do, right, it's hard to change it because people get signed up to it emotionally, and money gets poured in, and it takes a fair amount of effort, time, and money to do anything, whether it's hardware, software, nanotubes, whatever it is. So the important thing is to pick the right projects, because once you get going, you're on like a train basically. And this is even more important in startup companies where you typically only have one chance to get it right. I mean, there's a few startups that pride themselves of having change course in the middle, but that's the rare exception. Most companies that have went down the wrong direction will fail. So the most important thing is to pick the right project that makes the big difference, that you can achieve, that you have the right expertise and the right people that can make it happen, the right tools. I mean, all of these things play together. So basically it's understanding the problem in the market that needs to be solved, that needs a better solution, the best technology that can be applied to that problem, hardware, software, cloud, whatever, and then getting it done efficiently and delivering it to customers. So it's a very predictable cycle, actually. It's just when you start on the wrong track, you never finish.
Yeah. How would you then explain the success of Twitter? Because I think the founders, I heard one of their talks, they talked about pivoting. They were, had no idea this 100 whatever, chapters will succeed and be a phenomenon.
I don't know Twitter specifically, but there's a lot of companies, startups out there where the founders say, we had no idea what we're doing. I actually don't believe that. I think they usually knew exactly what they're doing. Otherwise, they wouldn't have gotten there. So it's the rare case where people stumble on something, as they go along. It's usually well thought out from the beginning. Another question back there?
Yeah, my question is, you listed the 5 basically reasons why a company fails. So how do you assess the risk from the beginning?
Let me go back to this slide. This is perhaps the most important slide in this talk. Here, timing is everything. In other words, there have been examples of great ideas that happened at the right time, but they wouldn't have worked out if it was just 6 months later or 6 months sooner. In fact, Sun Microsystems, the reason I dropped out of Stanford, quite frankly, was I had a choice. I could finish my PhD or I could start this company. So The trade-off was, if I had waited another 6 months or so, the company, that opportunity may have been gone. So my thought at the time was, I start the company, then I come back and finish the PhD later, but I never came back. So, I'm not encouraging, by the way, anybody to drop out of Stanford. I don't think that would be good advice. But what is true is that some of the most successful companies out there, including the Googles of the world, started at exactly the right time. If they hadn't had that insight or the cheap hardware or the Linux or whatever they needed to build that website, they couldn't have done what they're doing 2 years earlier, or 2 years later would have been too late, or even 1 year earlier and 1 year later. So most great ideas had a very specified horizon where they actually worked.
So we have some questions coming in from the webcast. And
yes.
One that's bubbled to the top, at least right now, is what do you see as the biggest threats to this cycle of innovation? Why might it not go on?
Well, there is not much threat on the technology side. So let me say up front, as long as the chip companies are not running out of money to fund new factories that can drive more slowdown. So that would be a separate problem. But assuming that continues, there will be better chips and cheaper compute cycles and more memory for the next many, many years, which drives cost performance and enables new kind of products to be built. There's no shortage of smart people. There's a lot of smart people in this room at this great university. So the expertise and the technology basically exist. There's lots of problems that remain unsolved. So none of those are risk factors. One of the minor risk factors is that the whole venture capital cycle is a little more difficult these days because it's basically harder to go public. So VCs had a harder time to get the money back out of their investments. And this has to do with SOX regulations and other. Basically, to go public these days, you have to be a large company. Whereas in the old days, you could be a much smaller company and then raise money and grow more quickly. So that is a slight negative, but it's not a showstopper. But the best ideas are still getting funded and will always get funded. And there's as much venture capital being spent now as there was spent 5 years ago. So it's, there is venture capital available. Sometimes it's allocated to certain areas more than others. For example, a few years ago, green tech was a really hot thing, right? Until it became clear that making solar cells is actually cheaper in China. 15 years ago, I think graphics chip was a really hot topic. So there was actually 30 graphics chips company in the mid-90s, and the only one that really made it was actually NVIDIA, who is the founder sponsored this building. So basically, I guess social networking is still a hot topic now. There's still companies getting funded to do different kinds of social networking, although it actually may be too late to get up against Facebook. So the best thing is to be at the beginning of one of these curves, not try to emulate something people have done, years earlier. So it's usually the new problems that are the most promising to solve, not some legacy problem. But people are still, moving databases to the cloud. I mean, there's big efforts going on to convert all of conventional IT to a cloud service business, and this is a huge total market opportunity. So the companies that are good at that will do really well, no question.
Why did the Apple Newton fail?
Well, that was too early. Right? This is the whole thing, which is the early Newton, and I don't mean to single out, but also the Palm Pilot and the, what was the company that was even before that, EO or Go, which became EO. They all had this notion that, you could use a stylus, which already was a mistake because, you always lose the stylus. And then the compelling benefit was essentially of an electronic notepad where you could take notes or look up your addresses or something like that. And that just wasn't a compelling use model, right? If music was useful because people love to listen to music, and being connected by phone is very useful, or by the net to have your email. So the first thing that really combined, email browsing, web browsing, and the conventional phone with all the other applications was in fact the iPhone. The previous things just didn't have a big enough screen or didn't have the same use model. The old Palm phones, they had the tiny keyboard. I mean, my daughter thought it was good for her because she could type on this. I never knew how to use this. Whereas, a lot of it has to do with usability. So basically all prior things before iPod, iPad, and iPhone just weren't that user-friendly. And Apple's most remarkable achievement is to make it that simple to use that there's no more manual, right? You take the thing out of the box, you turn it on, and you know how it works. In the old days, people had to read the manual first. It was a big change. Professor Knuth.
A question from one engineering hero to another engineering hero.
So my question is actually, I guess, very naive, but it seems that one of the main lessons you're having is that somehow Moore's law goes on automatically, and research and development is important. Now, so what do people in the business world mean when they say research and development? To me, research is innovation, and development is making better chips and so on. If you throw away research and development, are you just left with marketing?
No. There's a lot of the problem with R&D investment is this curve, right? In traditional companies, the vast majority of R&D goes into the existing products, and rightfully so, right? I mean, like say you're in the car business, right? You make another car, has a slightly different shape or maybe some new radio or whatever, but it's not that much change from the last year's car, right? So you spend a lot of money tooling it up and perfecting it or whatever, but it's really hard to make a big change. And gambling on electric cars hasn't worked out for most people. Whereas in high tech, the real risk is that you don't invent the next big thing. So of course, I mean, a traditional company like say an Oracle company, they have to get the database perfect, and if there's any bug, they still have to fix that. But then to completely change that model to a different kind of, say, Hadoop data analytics may actually be difficult for them because that's just not where their home turf is, right? And that enables new companies to do data mining grand scale, which is very different than a traditional structured kind of database. So it's one example where the problem you're trying to solve changes underneath you, and your existing product is no longer a good match to that, and what you really need is a very different kind of product that is just optimized for the new problem to be solved. So there's lots of opportunities in big data right now where there's apparently not enough people graduating that know this stuff for all the employers who want to hire these people. I mean, it's one of these shortages of talent in the industry, a combination of statistics and understanding mathematical modeling on large data sets. But I'm sure, some of those people may be in the room here. So it's, again, let me say this differently. The reason that a startup can even compete or ever get successful against an established company, right, which is not a normal thing, is that it's focused on this one new thing that really made a difference that the big company missed out on. That's the natural law here, right? And if this little thing, so the startup company is a fraction of the resources in terms of R&D of the big company, but the big company spends 97% of the resources on legacy stuff. So the real investment even a large company makes in future things is single-digit small percentages. And as a startup, you can actually compete with that level of investment, surprisingly, because you're spending 100% of your venture capital dollars on the new thing, and you're spending zero on the old stuff. So that is what makes the venture model even work. Otherwise, it would never work. Oh, sorry.
Besides cloud computing, what do you think are the top 5 areas that need innovation for the future?
Oh, this. Okay. I don't know what to say. Some of this has to do with, are you talking about startup versus big company? But let me say this differently. Every company, large or small, has to innovate in whatever field they're in to not fall behind. So that goes without saying that the companies that are growing the fastest are the ones that actually consistently drive innovation in whatever field they're in. And let me talk just for 1 second on my latest startup called Arista Networks, which is not the subject of this talk here, but we have now a mid-sized business. We have now 450 employees, 250 engineers, but and we have a decent revenue stream. But our real challenge is how do we get to $1 billion one day so we are meaningful? So that our innovation is how do we grab market share from much more established companies and differentiate the kind of product we're building to gain this kind of ramp, and keep growing on this ramp we're on. So every company has a different problem, if you will, where they need to innovate. So our focus is on this, particular ramp we're on. Other people are focused on big data analytics or solving problems that haven't been solved before. So there's no simple answer. But from a startup, return on investment model, obviously the best opportunities is where there's a future large market opportunity that hasn't been discovered yet. Because then even a startup can grow very big. So those are the best cases. But even a decent-sized market opportunity is a very valuable thing to go after. What you don't want to go after is just some tiny opportunity that never really pans out. So the opportunity has to be there because that's sort of the payoff at the end of the day. But there's no simple formula that says, that investing right now, say, in virtualization technology is more better than in cloud stuff or big data, right? You have to be the expert in your particular field and have the knowledge of the competitive environment in that micro segment of the market that you're going to pursue and truly understand why your thing, the thing that you're building is going to be better than all the other things that already exist or that other people may be building. So once you have that insight, you're usually on a good path, and you have the confidence because you did all this market research and the knowledge of the technologies that you can get there. And that confidence then attracts people who want to join you, and the whole thing sort of takes off. And once you're in a role, it's easier to hire people. But very early on, some people may wonder, is this going to make it or not? So whoever starts the company has to explain to the next 10 people, why it's going to work. So more questions?
So failure is a part of innovation, right? So especially for high-risk innovation, there's a large failure rate. But I was taken aback when you said that Apple has not had a failure for the past 12 years, but they've been the most innovative company. So I was wondering your thoughts on that.
Well, they had a particular good process, and I don't know any more about Apple than I read in Steve Jobs' biography. But it's clear that they had they had lots of discussions, lots of meetings about what should they do. They would test this with themselves first, where they had this whole lab where they would look at every alternative product design and then pick the best ones. It was a very methodological process that appears to be unlike other companies. And clearly that was a big part of their success. It was driven by the people there, led by the CEO. And the general belief is they now instilled this in their culture so much that they will keep going in this way. So that's certainly I would hope for. But going back to failure, one good thing about Silicon Valley is that it's not the end of the day if a particular startup fails. In fact, people are very good about deciding whether there was a market failure, a product failure, or sort of a lack in effort, perhaps. But good people who start a company that fails have every chance to go to another company that succeeds. Whereas in other countries, quite frankly, if you borrow money from somebody or the bank gives you money and you fail, then you have to pay back the money that disappeared for the next 30 years. You're basically, you can't do anything else. So I do understand, like in India, this is particularly rough. Like in India, you can't lose anybody's money. So that's this one reason that there's relatively few startups in India at the high risk stage. Whereas here, as long as the venture folks still trust you after the first flop, you can actually still succeed. But in any event, people who work at a company that doesn't go anywhere can always go to another company. There's hundreds of startups in this valley, right? So there's no career risk about joining the wrong company. What you don't want to do is stay at a company too long that isn't going anywhere, because that would actually be a bigger negative in your career. So if it doesn't work out, you might as well go to a better company. But generally speaking, there's no career risk in Silicon Valley.
Given the hurdles of successful innovation in large companies, is it a risky investment to invest in a large company that depends on continuous successful innovation?
Well, this is an investment question. So what you're
a good investor.
What you really do when you invest in public companies is you take a certain market risk. Most stock moves are actually market related. I hate to say it this way, but if the market goes up, everything goes up. If the market goes down, everything goes up. At least I think half of all motion is market related. And then there's the company element, which is this company doing better than the market, right? Or the industry segment the company is in, is that doing better than the market? So you can have a high return on investment if you have the right company in the right market segment and the market goes up, right? But that is much more, in the average, the stock index now is the same way it was 10 years ago. So the average index hasn't done anything, right? On the other hand, if you bought Apple shares 10 years ago, you would be very happy now, right? So this is this big gap in terms of identifying what stocks work or not. And a lot of people on Wall Street spend their whole life trying to do that, and some of them are more successful than others. But it's a weird way to spend time, basically. So I'd rather build better products. On the other hand, to add to your question, the investors in successful new companies have done particularly well, right? If they pick the right startups. So that goes without saying that some of the highest return investments have been new companies, including for the employees in the company, right? So that is the whole magic formula in Silicon Valley. It's a completely different risk. This is just the risk of making it as a startup and then getting acquired or go public one day, which is very different in a big company where people try really hard, they improve 10, 20% a year, but the stock is still the same because the market went down 20%.
Is crowdsourcing financing a fad, or is it going to fundamentally change the ways companies are?
I'm not the expert on this, but I doubt it's successful. And let me tell you why. Basically, when you start a company, it depends what kind of company it is. If you do like a iPhone app, you can do that by yourself or with 3 buddies. You can do that on your credit card later. You don't need any money. If you want to build something bigger and you need $1 million, then or several $1 million, it gets a lot harder because it's, in my opinion, unlikely that crowdsourcing or crowdfunding will want to pony up millions and millions of dollars. And the issue is, if you don't have enough money to get to your target, you might as well not start because you're not going to finish, right? So you have to have enough funding, or at least a path to the funding that allows you to be successful. Otherwise, it's all wasted. So crowdsourcing funding may work for the smaller kind of ideas, but it's not going to work for larger companies, in my opinion.
You mentioned Arista briefly and the horizon effect. So what's beyond the horizon for Arista?
Well, what is true is that we're also very much customer driven, meaning we basically do the things we need to do for requests as customers have, new protocols, new features, and that is the biggest acceleration to our business, is just to do more of the same, which is a proven business model. But if the business were to change completely, which I don't think it is, but that would be a more challenging thing for us, because that would mean we have to do something else. So as long as we do what we're doing, the business stays stable, we can actually ramp predictably. But if there was, for any reason, a rapid change in the market, that would be challenging for any company, including for us.
Andy, do you have an opinion on the importance of patents and protecting innovations? Whether recent changes in the law are going to change it?
Yeah, that's a very sore topic. I don't know. Basically, it costs very little to file a patent. You can file it yourself. It's, I think, a $200 filing fee or whatever. It costs a lot of money to assert a patent or to defend against a patent. So basically, if you are a company and somebody accuses you of a patent violation, or you want to accuse somebody else of a patent violation, the bill for that sort of lawsuit is millions and millions of dollars, depending on how extensive it gets. So this is something big companies do a lot because they want to assert their rights against others. But for startups, basing your strategy on, and obviously you can use patents to defend what you have, right? But to assert them is a very expensive proposition. It usually only makes sense if you're a big company. So I guess it's a good idea to file patents so you have a whole bunch, but it's very hard to actually monetize them or assert them, unless you have a really deep pockets.
When you invested in Google, did you know or did you foresee that the company would be where it is today?
No, I don't think anybody foresaw that, including the founders, by the way. But what was clear to me is that they couldn't go broke, because I thought there would be enough people clicking on the links that they would actually pay for it. They would be at break even very quickly, which is what they did. But the fact that it then ramped so quickly, just nobody foresaw, including myself.
You talked a lot about data mining, big data. I'm curious your perspective with respect to IBM and innovation in an extremely large company, and your thoughts around that.
So IBM is an interesting company because from all the big IT companies, they have the most research labs and have invested very heavily in innovation in particular, both at the software level and sort of hardware things. So it is an example that you can drive innovation as a very large company. But I think still somewhere IBM is wondering how they're missing out on more things that are happening in Silicon Valley, right? So there's this sort of gap between, yes, we're the big company and we can place big bets, but the problem for IBM is like a $100 billion company, right? So for them, if it doesn't do like $1 billion, it doesn't move the needle, right? So they tend to miss the smaller opportunities, like a 10 million opportunity, which is a great thing for a startup, or even a $100 million one, because it only gets interesting when it gets big enough to actually make a difference, and they can always buy the startup. So they tend to perhaps move more cautiously in new things once it's more proven, but it's also a company that's willing to do that for the right opportunities, including a lot of software lately.
So Andy, a lot of people out on the web want to know what you think about autonomous cars. Right? Is it too early?
I wouldn't go in one.
There was a slide you showed where you gave percentage of ideas coming from different segment of people, employees, research dollars. How much do you believe in that slide? And if you had money to spend in a large company, where would you spend? Would you spend in that proportion?
Yeah, the problem with big companies is that you have so many ideas and so many people that all want to promote their ideas, and it seems like a good idea, but some people are more risk-averse than others. You get this almost like cacophony of voices of what to do. So I think one reason for Apple's success is that they have a much more streamlined sort of management structure, and basically one decision maker on the top and done deal, right? That actually can work much better as long as those are the right decisions than any other approach that's more sort of democratic, if you know what I mean. And it's just a question how companies operate internally. Now there's counterexamples. For example, 3M, which is not a computer company, has apparently very, very well organized around multiple business units that invent Scotch tape here and other things there, and then many, many different businesses like that. So it depends on the type of company, but in IT companies, the different voices can be quite amazing. imagine you are at HP right now with, 350,000 employees, and the question is what to do. Do you go more into software, more into services, more into hardware? Where do you increase investment, do you decrease investment? Those are very tough choices, and many people have many different opinions, but you're going to spend a lot of time on that question, and you may miss the next little thing that turns into a big thing. So every company has just different reason for existence and is in a different situation here. But I do believe that employees are your biggest asset. That goes without saying, right? So in any company, it's usually the employees that work on the stuff, that define the strategy, that get it done, that say, I can do this, or we shouldn't do this. It's also important to pay attention to when they're saying this can't be done, that drive the success. They are the people who execute the engineering. So one has to pay close attention to them as well as to customers, because ultimately what you're building has to resonate with the ultimate customer.
If you're going to be advising some of the engineering students today, would you tell them to focus and get very, very specific, narrow it down, or would you say, get focused, but always put something out and study other fields just to get the cross connections?
Yeah, there's no general purpose of it. We actually talked about this at dinner earlier, which is, if your interests are very narrow, and you really want to specialize in, say, Hadoop big data for right now, right? You're a highly desirable employee to a lot of companies, so you have you can choose where you want to go to, any number of companies. Whereas if you're not as sure what you actually want to do, and you're more the generalist, you're still interested in many companies, but you wouldn't be as vertically aligned with a particular one. So it's actually easier for the person who's very vertically to make a choice, in both directions, the company choosing the person, you choosing a company, than a person who's more a generalist, right? But the world lives of generalist people, so the truly narrow people that really excel at something are the rarer breed behind, but they're usually the ones who actually start the company because they're so convinced that they know how to do this, they just get it done. So in my own case, right, I went vertically down to build this workstation, and I just did it by myself essentially, and it was, smooth sailing afterwards. But if I didn't have that focus, I could have never done it. So, let's start here.
So, question on your, I want to understand I want to hear your thoughts on the emotional aspect or the persistent aspect of innovation, in the sense that what I read is Intuit, the founder, when he went out to VCs to get funding, he was rejected like 30 times before getting funded, and Intuit is a big.
There are stories like that.
I want to hear your thoughts on that.
Well, there's a lot of stories of people in this valley which are typically not Stanford graduates, but people have all kinds of business plans or business ideas, and actually know some of them myself. They keep trying to get their plan funded, right? And if it doesn't get funded, they come up with another plan, and they just keep generating more plans until they get one that gets funded. It's like scripts in Hollywood, right? If the first script doesn't make it, you write another one, and eventually it becomes a movie. That's not the recommendation. You can spend a lot of time doing that. You have to pick something that has real value, to future customers, and where you're the expert in the technology to succeed more quickly. And those plans typically are the better plans. So the ones where people go round and round are not the good ones. But back to Intuit, it was actually a good idea. And maybe people misjudged the value of the idea. And this, it has happened in other segments. Facebook early on didn't get a lot of funding because people thought it was crazy. But in the end, everybody thought they wanted to be part of this. So, question?
So it seems to me like in the early days when the ARPANET, most of the things, the innovations and things came because people kind of ignored it. But now it's become billions of dollars business, so it's starting to aggregate into a few companies, and the government also becoming a lot more controlling. So do you think that's going to kill the chicken that's been laying the golden egg, and that innovation in the web and the internet will cease? Or
yeah, so let me answer this a little differently, which is back then it was in fact easier to start a company.
Yeah.
I'll volunteer that here firsthand. And the reason was that the existing large companies were not the early adopter of the new technologies. I mean, the IBM had the mainframe, Digital Equipment had the mini computer, but they were very comfortable with these businesses, and they didn't see the threat below, right? Whereas if you try to start a company today in those same businesses, you would be up against Microsoft and Intel and NVIDIA, or anybody that's already is actually a startup company and is very successful at it today. So that competition is much tougher than it was competing against IBM, DEC, and HP in the early years of Sun, for example. So it would probably make little sense today to start another server company because server margins are declining, and it's just not a promising field, so to speak. Whereas most companies have missed the social network increase, so that is still an area people are investing, or the next big thing with big data. So you have to pick a thing that's ahead of the mainstream adoption. it is very tough to, I mean, you wouldn't write a new operating system today to compete against Microsoft or Linux, quite frankly.
Right, but just with the aggregation and the IT companies and things could restrict, only the big customers get served quickly. And
yeah, well, that's a different problem, which is, some customers just want to have the full support of a large vendor, and it's hard to break into those accounts. If that's your business strategy, you have to have a real value proposition that gets you through there. That's one of the more difficult targets these days.
A couple more questions.
Yeah.
It seems like the pace of innovation is, exponential. And 2,000 years ago, somebody would understand living 1,000 years ago, but somebody 200 years ago wouldn't understand an iPhone. And how does that going to affect society for her and that little kid over there?
Yeah, well, I'm not sure it's exponential. So let me back to different. The reason I'm saying this is that, yes, the growth of data has been exponential, no question there, right? But most of the data is actually useless. So the hard problem these days is filtering. Now, truly, the hard problem is filtering, I promise, okay? And of course, people growing up today, right, that grew up with an iPhone or iPad, have a completely different experience of what it means to be in this world. So, my daughter was used to the iPod, and we're driving the car and listening to the radio for a change. And she liked the song. She says, "Can I play the song again?" And I had to explain to her, I cannot replay the radio because it's not an iPod. True story. But the point is, the truly good ideas. I mean, even if you look back the last 10 years, right, there was the consumerization of the digitalization of the consumer experience. It was a truly great idea. We're not going to see another consumerization of digital, the same thing the next 10 years. Now, hopefully we can see the cloud adoption of enterprise computing on a consumer style that is like point and click to install an enterprise application. That would be nice. Today it takes weeks, if not months, to configure a new server storage network to solve a problem in the data center. Why is it so complicated? Well, there has been so many companies erecting walls to make that impossible that that's what it is. But that's actually not what the customer wanted, right? It doesn't solve the customer problems. We need, software-defined data centers, something that works a lot easier than what it works today, no question, right? And again, the question is, will this innovation come from, VMware, IBM, or from startups? And maybe it's all of the above, right? Because it's a big problem to solve. And existing vendors tend to want to defend their home turf, quite frankly. They try to extend the business and reach out, but they don't want to change it completely either. They can't. So it's, that's the interesting dynamics, which is if you think of this whole thing as a chess game, right? It's like, what are the moves you can make as a startup? What are the moves these bigger other existing business can do? And how do you play this game so you're going to win? It's really is an intellectual chess game at that level. And the strategy is, it's move by move, doing the right things.
Just wondering, a year ago, Bit Surf was worried about bit corruption. What 1,000 years from now people will do. What's your worry for?
Well, bit corruption is a potential problem. There's a certain error rate to data on transmission or otherwise, and you need fairly strong CRC codes and ECC codes to prevent that from happening, or to at least make it visible when it happens and be able to correct it. And this is true, whether it's flash memory or laser communication. It's a general problem in the industry. Now, the logic gates are still pretty robust, luckily. So if logic gates get flaky, that's actually a bigger problem. But bit corruption is essentially dealt with by strong hash checksums.
What do you worry about?
I'm not worried about bit corruption. So,
one more question.
Although I sometimes wonder if some data disappears, whether how could this have happened, or the computer crashes.
You started out the talk talking about Moore's law and the dramatic past and future predictions. But when you look at a system, it's more than just hardware. For example, components of software and communications go into a system. So do you see, and those things definitely have been done as well on that Moore's law.
Yep,
so do you see those as being an impediment?
Yeah, let me discuss briefly why that is. And this is actually, I cut out these slides because I thought it was getting a little too technical. So the speed of the transistors is not doubling every other year, unfortunately. In fact, it's barely going up. So when you talk about the I/O, the pins that come out of the chip, the ones that drive the laser, progress is like a factor of 2 every 5 years, which is much, much, much slower than Moore's law. So chips are going to be increasingly I/O limited in terms of there's only so much I/O, and the I/O doesn't go up with Moore's law. So people are working now on optics on the chip, silicon photonics to get more stuff off the chip, and I think that's coming along. But that could be a limitation, except the silicon photonics people think, they have this problem solved when it gets there. It does mean that networking, for example, is not on the same price performance improvement as is CPUs, because you're actually not doubling every year, unfortunately. But going back to one thing that it's not something I'm worried about, but something I'm wondering about, and just to set this bit in your mind here, is what seems clear to me is that the development of chip technology, by the time it's getting as dense as it's going to get, it sooner or later it will equal the number of cells we have in our human brain. So at the numeric level. So the fundamental question that has never really been solved is how one could build computers that work more like the brain, literally, than the traditional von Neumann model. And this does require a lot of parallelism, apparently, and a lot of analog kind of functions and God knows what else. But that would be very well worth to spend a lot of R&D on right now, because to me, this is a kind of problem that could be solved in the next 10 years. Whereas 10 years ago, this would have been too difficult. The chip technology just wasn't there. But there's only so many brain cells in the brain, and the future chips are going to be just as dense. So it is something whose time may come in the not too distant future. So if I was a student right now, that's what I would be working on. Just as a thought for the evening.
Great. So we have food and drink in the lobby outside. We welcome you to stay, and Andy will be available, I think, for a little while. We want to thank you on the attention.